Hi, everyone, and thank you for joining us for today's webinar, The Changing Landscape of Commercial Pool Operations. I'm Marianne Murphy, the Vice President here at the Medical Fitness Association. I'd like to take a brief moment to introduce today's presenters. Timothy Petsch, wave your hand, is the co-founder and managing director of TMI Sustainable Aquatics. During his 30 years in the commercial field, Timothy has been involved in all facets of commercial pools. He is a certified pool operator instructor and inspector and has trained and certified hundreds of pool operators. He has worked as a pool consultant on numerous projects around the country and is called on by many architects for his input. David Jerkins is the account manager and lead tech at TMI Sustainable Aquatics. Now, today's webinar is sponsored by TMI Sustainable Aquatics, an MFA industry partner whose mission is to promote the advancement of sustainable aquatics. Now, if you have any questions as we move through today's webinar, please type them in the chat or QA section of your toolbar, and all questions will be answered in the end in the order they were received. Okay, Timothy and David, take it away.
Thank you, Marianne. I appreciate that. Before we get started, I would like to mention that what we're going to cover in the next 45 minutes is our vision of what we expect and honestly hope that the commercial pool market grows into. None of us can predict the future, and as we all know, we're in the cusp of many changes in our industry. From AI, rising costs, requirements for sustainability, and others that we'll touch upon. So we feel privileged to share our vision of what we see on the horizon for the industry, for our industry. To be transparent and candid, we do have our preferences and they'll become evident. We look forward to your questions and comments at the conclusion of the webinar. Finally, we respect the general commercial pool service market. We simply don't always have the same aligned philosophies, and our criticisms, if any, are simply clinical. Is this one working?
Yeah.
Okay, cool. So what we're going to go through today are our learning objectives of staff training, pros and cons of chemical treatments, and technology. The pain points for most of you guys and most of the people we deal with running a pool is getting chemicals delivered on time, and having them be of sufficient quality. We've also noticed that in the last few years since COVID, chemical prices have gone up dramatically. Trying to get that chlorine odor out of the natatorium is a challenge sometimes. And just to ensure that you've got clean, consistent, and crystal clear water on a continuing basis is another issue that we seem to run into. And we're noticing that equipment is becoming somewhat antiquated. And of course, what we all try to do is to avoid swimmer complaints. So first learning objective is staff turnover. We know that it's a fact of life today that staff is turning over faster and faster as we move on. And a single training session is simply not enough. Most people will retain 10 to 20% of what you tell them in one training session. Heck, I've taught hundreds of CPO classes, and I can tell you that in 2 days, those folks don't walk out of that classroom environment understanding how to operate their pool. So essentially, when a new operator comes on, they are learning from the operator that was there. Hopefully, they get that passed on. If not, they'll get a bunch of manuals sent to them, and they've simply got to sort of wing it themselves. In fact, we've had folks tell us that their go-to resource was Google.
Many people.
Yeah. So the operator is left to his own devices, and if they're not experienced and they are running into some of the new sophisticated equipment, that could translate into inconsistent pool operation. What we believe is that in the future is that staff should be trained by the industry. With all the tools we have today, virtual trainings are, in fact, we know that virtual meetings, virtual trainings are occurred every day and do so today after COVID. So if there is a relationship between the pool company and the client, problems can be solved very rapidly with the correct guidance by the vendor. And that would result in what I have listed here: smooth pool operations, lower costs, and of course the number one criteria is no unnecessary pool closures. The second learning objective is understanding various chemical treatment options. And I'm going to start with and probably concentrate more on chlorine today. So David, over to you.
Thank you, Timothy. Guys, we're going to just briefly go over the three primary options that are used in commercial aquatics. And right at the top is, of course, liquid chlorine. This is the most common product that's used to manage pools. It has a relatively high pH. It's fed with a pump, and it can feed quickly. It does require that chlorine be added to a tank frequently, and if you have an empty tank, it means your water chemistry is going to suffer. Interesting note is that liquid chlorine is made from salt, and every time you're adding a little bit of liquid chlorine, you're also adding a little bit of salt. The next item here is calcium hypochlorite, or as we refer to it in the industry, just cal hypo. And that has a high pH as well, but slightly lower than liquid chlorine. It is shelf stable. It is a dry chlorine.
Contrary to liquid chlorine, because that can run out within 3 months.
Yeah, liquid chlorine is going to rapidly lose strength
Right.
while it's being stored, actually. But the dry chlorine being shelf stable makes it, one, you can just leave it on a shelf, and when you need it, it's there for you.
Is that about 2 years?
Yeah, around 2 years, sometimes longer,
Mm.
from what I've seen. But the way they make it dry is they put a whole bunch of calcium in it, in a nutshell. So every time you're adding calcium hypochlorite to your pool, you're also adding a lot of calcium to it, which of course is going to, exponentially raise your calcium hardness.
And affect your LSI, your Leglia saturation index.
Right. Then the last item would be what we call a saline system or a salt system. These typically run at a much lower pH than the other two options. It does require installation of specialized equipment in the plumbing that will basically produce chlorine from salt water, and it does require adding salt to the pool itself.
And I think, as we state on the next slide, that one of the drawbacks with salt is that it really can't catch up as quickly as liquid chlorine and cal hypo.
Right, it is slower to feed, whereas a liquid chlorine or even a cal hypo pool in particular, it raises chlorine like that.
Which is why liquid chlorine is rarely used to shock a pool.
Exactly, we usually use cal hypo.
Right.
So liquid chlorine pools, we often hear a lot of people commenting that liquid chlorine can cause itchy skin. For those of us with more sensitive skin, I get more bleach outs in a liquid chlorine pool. Liquid chlorine does.
Why is that, David? I mean, is that the sodium hydroxide in the liquid chlorine?
Or one of the many other ingredients that are in there. Yeah, to make liquid chlorine shelf stable as they can. I mean, if they didn't add these ingredients, the liquid chlorine would lose strength within a week, as opposed to 3 or 4 months that they do now. I think all of the other ingredients they're adding to that, they do harm water chemistry in some way. And you have to store this chemical on site. You have to transport this chemical to the pump room. And I've known one customer who had to bring it down a ladder, which I can't imagine. I don't see many people doing it, but you should be using PPE for cal hypo or liquid chlorine. The upside is liquid chlorine is incredibly easy to source. You can find it anywhere. You can go to Home Depot and pick some up. Cal hypo, way more maintenance time than any other option. The tap feeders, while they're cheap, they require frequent cleaning.
And I think if anybody in our group today has cleaned a cal hypo feeder, they're sort of nodding their head at you right now.
Yeah, it's pretty nasty whenever it gets that white calcium buildup in the bottom of the feeder that you have to scrub out, basically. Again, cal hypo has an excellent shelf life, but more importantly, it's incredibly easy to dump into a pool. If you have some granular cal hypo, you need it for fecal events anyway, then you can quickly bring your chlorine up to breakpoint chlorination per the CPO manual. Again, it does constantly increase calcium hardness. If you're using a saline pool, this can be retrofitted on most pools. It doesn't have as much maintenance as compared to something like a tab feeder. And of course, it means less chemicals on site. You're not going to have as much chlorine on hand, and incidentally, you won't have to have as much acid on hand.
And I think the key there to doing it right the first time is to ensure that it's sized correctly to your particular use, your particular pool, and the flow rate of your system.
That is very important, and I really recommend that you always work with a company who knows how to size a salt
Right.
system. That's not always true. Sometimes they'll size one that's just, they say, this system's good for 25,000 gallons.
I think that happens in residential pools.
It's a residential thing,
one
yeah.
pound for every 10,000 gallons, I think, or 20,000
Yeah,
gallons. something
yeah,
like
that's really the comment.
right.
So let's talk about other chemicals that you guys are using in your facilities. And one of those is you're going to be using a chemical to manage your pH, and that's either going to be acid or CO2. Those are the standards. I'm going to talk briefly about acid. Acid is, again, readily available, just like liquid chlorine. You can find it everywhere. It's cheaper. It is the most dangerous substance you have in your facility if you have acid, period. We've seen the results of those kinds of accidents.
And one of the things is do you mix your acid? One of the conundrums of a pool operator is, do you mix your acid to lower the strength of it, or do you use it pure? If you use it pure, you're going to be looking at lowering your total alkalinity. So
A great deal, yeah.
that it's like anything in a pool. The way to understand what to do with your pool is to understand what your source water looks like.
Yes, 100%. If you, depending on the total alkalinity and the pH of your source water, that could dictate which of these
Which
really
way
want.
you go.
Yeah.
Yes.
The other option, of course, is CO2. CO2 is safer. It costs more. It's sometimes a little more difficult to source depending on where you are. I have some customers in Alaska who have difficulties getting CO2 year round. And it does the opposite of acid. It will raise your total alkalinity,
Right.
which is exactly what you're talking about.
Correct.
Depends on the source water.
And you're going to talk to us a little bit about technology.
Yep.
Now, I know that there's some automated controllers that are out there that can actually use both. So you can use an acid and actually a CO2 as primary and an acid, and it can automatically ensure that that total alkalinity doesn't push you up over
I
LSI.
love it whenever I can work with someone who is using both, because we can actually use both to dial that in. Yeah.
Okay.
Dechlorination. We all have to do it sometimes. Now, the standard in the industry up to today is still to use a product that contains the sodium thiosulfate. There are other products out there, but this is the one that is extremely common out there. There's two major issues, and I call them major. One is it's adding sulfates to your water, and two is you're killing fish by using it. On the first
Do you
item,
have fish in your pool?
no, but every time we backwash, every
Yeah.
time we have a pool that's anywhere around waterways, that pool water is going to end up
Okay.
in our local waterways. Mostly on an outdoor pool, especially if you have washout, that kind of thing, ends up in the groundwater, ends up in our local waterways.
Not healthy to.
On the first item, sulfates. So Portland cement, the people who designed the formulas for Portland cement have created, they've created concrete that's resistant to everything, including salt water, but sulfates are one area where they suffer greatly. There is a sulfate resistant concrete, but I don't know any contractor that uses them, unfortunately.
Probably very expensive.
That's why. Yeah. So I never recommend, and I actually have a blog post on this I'm happy to share with anybody interested, that talks about why you should never use sulfates in a pool, period. And that includes products like non-chlorine shocks, dry acid, and of course, thiosulfate.
So in the changing landscape of pools, we're looking to move to a more natural.
Vitamin C.
Right. Okay.
Yeah, if you use vitamin C, obviously there's always a downside. There's always a catch.
Yeah.
It costs more.
Yeah.
You have to use more of it to bring the chlorine down.
More, is it twice as much?
Yeah, no, not that much, but it's, I'd say maybe 50% more.
Okay.
It's safer to use, and you have the opposite problem. I suppose fish love it. Fish actually can't naturally produce vitamin C in their bodies, so they only get whatever they consume.
So it's actually a positive for
It's
the
a positive for the
environment.
fish, yeah.
Okay.
And then that leads me to, I mentioned non-chlorine shock. Don't use non-chlorine shock when you can avoid it. I actually know some people who they have combined chlorine problems often,
Yeah.
And their solution is, the right way to do it is you have to shut your pool down for X amount of hours, sometimes 24 or even longer hours. Bring your pool to breakpoint chlorination to drop that combined chlorine. And nobody wants to do that because it's a pool closure.
Sure.
I understand that. What we should be doing instead is using a UV system, which we'll
Which
talk
we'll
a little
get
bit.
to,
Yeah.
yes.
But I know customers that use non-chlorine shock. Non-chlorine shock, again, sulfates.
Wouldn't that be comparable to saying that if I want to manage my pH, I'll wait till it gets to 7, 8 or close to the high level, and then I'll dump a bunch of acid in, so I'll drop it all the way down. And then
little
all
bit.
it does when it's dropping down, it just starts going back up again.
A little bit, if you
Yeah.
wait that long on your combined chlorines, yeah.
Right.
It's something that should be always managed to prevent chloramines, which we'll talk about. And then lastly, specialty chemicals, be very careful with those. There are a dime a dozen. There are so many of them. And, we mentioned acid and CO2 also affecting your total alkalinity. During my trainings, one of the things I always tell people is that, we're putting all these products into our water and they always do something that we want them to do. But they almost always also do something we don't.
There's a knock-on effect.
Yeah, there's always something we don't want. There's always a side effect. So be careful on what you add.
Well, you encourage your clients to put as fewer chemicals in the pool as possible.
I try to keep it simple.
Right. So liquid chlorine, Cal Harpo, we just know these facts. It's old technology. It's dangerous. It's going to cause swimmer discomforts. I mean, it's the only reason you get out of a pool and head to the shower. So what we drive towards is to try and find a safer and cleaner technology, a technology that will allow the swimmers to get out of the water and say, wow, what did you do? This is fantastic. I love it. If you've got a product, and of course, we're the Salt Pure company, if you have a product that is closer to pH neutral, you're going to have a less of a problem keeping it balanced to LSI. And of course, as I mentioned in my intro, we're all trying to get as sustainable as we can. David, would you talk to us about chloramine?
Absolutely. I
Your
mentioned
favorite.
combined chlorine.
Yeah.
Yeah, I mentioned combined chlorine and, how we address it. You have to shut your pool down, bring it to break point, or you have to use a non-chlorine shock, which I've already advised against. The proper answer would be to use a UV system.
May I ask you a question?
Yeah.
Do an excess of sulfates in the pool, this is to the folks out there who might be using non-chlorine shock.
Yeah.
Do an excess of sulfates in the pool cause member skin irritations from a skin
You can
irritation?
actually. I actually
Are there
have
people who are allergic or somehow more sensitive to sulfates?
not really allergic, and I actually have some articles I've read and I can recommend on this subject. But if you have enough sulfates in the water, it's actually going to form a silicate, and it can actually form that silicate on the bottom of the pool, and it can actually be sharp, and people can hurt themselves on it. They can catch their feet on it. And if it's bad enough, I'm not talking like gash their feet, but it can be some discomfort.
Uncomfortable.
Exactly.
Say swimmer complaints, we'll go back to that.
Exactly.
Right.
Yeah. So by using a UV system instead of, shocking, we can keep our combined chlorines low, which means we are going to be removing those chloramines before they ever have a chance to off gas from the surface of the water, which is really important.
And the beauty with UV is that it's plug and play, kind of, sort of, and you'll talk about that. And it's also sustainable. It's a
So
wavelength.
what we recommend are low pressure UV systems.
Why is that?
They perform as well as medium pressure systems. So let me put it like this: medium and high. There are high pressure UV systems out there as well. Were originally industrial equipment. They were used on water drinking plants, that kind of thing,
Sewage plants.
where they're treating literally millions of gallons a day of water.
And they're treating very, very high levels of chlorine.
Of course.
Which means high level of combined chlorine too.
And so they need those systems. They take those same systems and they sell them in aquatics, of course.
Mhm.
And there is a place for them. If they, if you have 800, 900, 1,000, if you have really high gallons per hour, you may want to consider the medium pressure UV. But for most of us that are running, 300 GPM, something like that,
Mhm.
a low pressure is going to do the same job, but for much less.
So on the benefits of UV, can you talk to that?
Yeah, I can talk a little bit more about
I mean, there's two levels. There's sort of
there's the chloramines.
right, but there's a benefit you want to sell your clients. You
Yeah.
know, what do I want to give them? Do I want to give them the best experience? And then there's the mechanical or the hard tech benefit,
There's the
like the building.
the chloramines that are off-gassing in the air are going to, chloramines are actually, other than muriatic acid, the most corrosive thing in a facility. And if you have chloramines off-gassing from the top of the pool, that's going to get sucked up into your HVAC. And if you don't have the greatest HVAC in the world, it might just hover around your pool area and start corroding things in that space. But it's going to damage your HVAC unit over time. So taking care of those chloramines is really critical for long term. Then there's also the things that nobody really likes talking about in the industry about, because it's a fear-based thing. Talking about pathogens and parasites that are resistant to chlorine. We've been using chlorine for over 100 years now, and there are some things that are starting to build up a resistance to it. And UV will tear those apart literally to prevent them, so you don't have to worry about them in the water. Cryptosporidium is probably the most common.
Yeah, and I think when we talked pain points at the beginning of this webinar, we talked about complaints.
Yeah.
And that's one of the major complaints we hear is that, well, I hear just around the industry is like when I walk at the front desk, I know they've got a pool because I can smell it.
Yeah, everyone always, a bit of a
Thinks that
myth.
the smell of
Yeah,
chlorine.
they think it's chlorine that
Yeah.
they're smelling. Everyone walks in and goes, "Oh, I smell the chlorine." No, you're smelling the bad used chlorine, basically.
Right, the
Yeah.
chloramine, which is the ammonia that's mixed with chlorine. Okay, we're going to jump over to technology. And David, you're going to take this
You're
one.
going to do some more talking.
Good for you.
So, guys, we're actually going to spend a few minutes talking about the equipment of the past and the equipment of today and tomorrow. And we're actually going to start with the pump, which is the very first thing typically in a plumbing system. Now, in the past, pumps were very simple. They just had an on-off switch, they had a fixed rate, and they were pretty big, depending on your pool. And what I mean by fixed rate is they ran at a fixed RPM. And what I mean by that is that's how fast the pump is
It
spinning.
didn't, the only reason it would change is if the pump had a problem.
Exactly.
And it started breaking down.
Yeah.
Right.
And then that means you end up with a fixed flow rate. So years ago, we just had to size these pumps for your flow rate. Nowadays, though, and this is actually greatly spurred by the Department of Energy, particularly over the last 5 years, the DOE has started requiring that the pumps manufactured be able to change their RPMs. Newer pumps are going to be VFD driven, which
What's
means
VFD?
it's a variable frequency drive. That means you can control those RPMs.
Okay.
So what you do is you set it to target a specific flow rate. Let's say I need 300 GPM to meet my minimum turnover, and I'll target that, and then it will control the RPMs of the pump to meet
that flow rate.
Exactly.
Okay. And would it pick a lower RPM if it can? Is it
Yep.
that
Yep.
I guess thoughtful?
Yeah, and if you change your filters, you backwash your filters, the flow changes, the RPMs change. It goes up and down as needed to meet it. What this means is you don't end up with a lot of wasted energy, which is energy savings, really,
Right,
is what it
right.
boils down to.
And just by putting it in, just by the fact of installing it, you're going to start saving electricity.
Immediately,
Yeah, right.
If you're going from a fixed rate to a VFD driven pump, it's immediately noticeable. Speaking of immediately noticeable,
It means the spaghetti over there.
yeah, filters are one of the areas that have seen tremendous changes in the last 20 years. And this is actually an MFA member. This is Logan Helm. They're in Kalispell, Montana, and they had some giant vertical sand filters for their large lap pool. They had all that pipe spaghetti, as Timothy said, all of those valves. This is typical 20 years ago. This is what we had to do. You have to backwash these filters frequently. You have to know which valves to turn.
Don't touch that valve yet.
You have to turn them in the
Yeah,
right
because
order.
it could cause a catastrophic event.
And it has a huge footprint. That's a filter. That's a typical sand filter. Now, this is the same place. This is that same side of the room today. This is a regenerative filter. And this is kind of where the industry's been going, is being able to reduce those footprints from, I just want to go back again and show you.
Yes.
Going back
I
from
was going to
this.
ask you to.
to this is such a night and day difference. The footprint is crazy, and no more backwashing. So I mentioned you have to backwash the sand filters, which you're reversing the flow of water to get rid of the dirt that's on the bed, and you're sending that to waste. Which, if you've been using sulfates, now you've put those in the water.
Right.
And you don't have to do that with these.
Tell us how these work. I mean, why don't they exhaust water? How do they clean?
So with
And there's got to be some work involved.
of course there is,
Okay.
yeah. But with a sand filter, you have a flat bed of sand,
Right.
and the water passes through it and catches the dirt. It's as simple as that.
Like a coffee filter, but sand.
Yeah, that would be your filter area. That's how much filtration you have.
Right.
That bed. Now, with a regen filter, this device here has rods throughout of it,
Okay.
and each one of those rods is coated in perlite, which is similar to DE but much safer. And each of those is acting just like that filter bed. So you're able to kind of compact all of that filtration into a very tight space by just having all of these rods in a can, so to speak.
And it, instead of backwashing, it bumps.
Exactly. We
Which
call
could
it
be
a
done-
bump.
Which can be done remotely too.
It can be
Or
done
better.
automatically. Yeah, it actually will do it at 3 a.m. for you. And the best analogy I've come up with it is if you have a sand filter, you have your filter area and it gets dirty and you have to backwash it and send it to waste. With a regen filter, you have your rods, they get dirty. Instead of backwashing it and sending it to waste, what you do is you do a bump. You shake the rods, all of the material falls,
The
and then you
perlite and the
reapply.
dirt.
Yeah, and then you reapply them. It's like if I take a piece of paper and I scribble all over one side and it's completely dirty, I can't use this piece of paper anymore. But if I flip it over, I can keep using the same piece of
Okay.
paper. But you mentioned work. Eventually, no matter how many times I flip this piece of paper, I still can't write anything new on it. So at that point, you do have to change the media.
Okay.
So at that point, it is like backwashing. You have to send it to waste.
Okay.
Um,
But a lot less frequently.
Most of my customers that work with these filters every 3 months.
Every 3
And
months.
that's about where Logan Health is actually.
And what the manufacturers state is that if you look at the cost of water, the waste of water, this can actually cost justify itself over a period of
There
time.
is an ROI for this. And
There is, okay.
in some areas of the country, like California, who have drought
Yes.
seasons,
Yes.
they're not allowed to drain their pools. They're not allowed to do anything with their water. This could be a lifesaver for them.
Could be, or a business saver.
Yeah. Heaters, well, we're taking energy and we're transferring it into heat for
Yeah,
water.
1-to-1.
Well,
Not really.
Not really. No,
Not really.
we wish it was 1-to-1.
Yeah.
Efficiency on older heaters sucked. Like you were lucky to get 70% 20, 30 years ago. They were also pretty simple, on, off. You got a thermostat that'll turn them on and off. And back then, most heat exchangers were just copper. Nowadays, though, we have heaters that almost are at 90%. We're getting closer and closer to being as efficient as possible. We have electronic ignitions on them, so they will start and stop themselves, which means you don't have to, wake up at 2 a.m. to light your pilot light again. And most heat exchangers are copper nickel now, and nowadays I actually have a lot of titanium on.
Yeah, we've seen that come out as almost a standard.
And they integrate with a lot of other devices, so you can control them with a chemistry controller, for example, or at least integrate them.
Correct. Testing of pool water, probably one of the most subjective things that happens around a pool. Essentially, what will happen is you'll take a reading and you will presume that it is a certain value. As you can see there, it's pretty difficult to tell what that pink color is exactly. And what happens with that is most operators will, or many operators will go to the chemistry controller and enter a value that is a subjective value to a microprocessor, which microprocessors are not subjective devices. So we find that this is lacking. It's one of the biggest problems I think that we face out there. Yes, because they'll go to their chemistry controller and they will change it, which is like changing your speedometer.
Mid-drive.
Yeah, mid-drive. Yeah. So what we've seen come out today, and what we've been testing, and a number of other companies, I'm sure, is an NSF-approved digital test. I don't know if any of you guys use them, but this one brand that we've chosen to use, and there are a number of brands, will do all your pool tests and more within 60 seconds. So it takes the guesswork out of it, and it allows integration from that pool tester into a number of other applications, which you'll talk about.
Yeah, and if it may jump in, it's not just, it does remove the subjectivity, of course, but it also removes a lot of the time that it takes to do that, those other tests.
Sure.
I have a customer, a resort, they have 12 bodies of water they're managing, and they have to take those tests at least 3 times a day. And if they do it with the old method, by the time they get done doing one,
12 by 15 by 3.
exactly,
Yeah.
they end up doing a lot.
That's expensive. David, if you would talk about the service versus
Service versus support. So in the past, there was just service.
or today, actually.
Actually today, yeah,
Yeah,
for most.
you call a pool company up for help, and it's next week.
So let's say one of you guys have an issue with a facility and you can't solve it yourself. So what you do is you call up a pool company. You have to wait for them to come out. Yeah, I can get out there next week
Yeah.
if you're lucky, honestly. It's a billable call. They don't always have the specific equipment knowledge that is necessary to do the job. And they're just there to fix the issue and leave. That's their job. And they don't actually educate you on how to correct this in the future.
Correct. And what we seeing now is that using technology, and we'll dig into that even more, using technology, you can actually solve your problems pretty rapidly if you partner with the right people.
Yeah, I see a lot of problems that don't need a full service company that could be handled by phone, quite honestly.
Mm.
And that's what we're seeing the industry move towards is companies that will work with you, that will call you, not you calling them, to make sure everything is functioning well.
Right. Right. And continuing that education we spoke about a little earlier. Now to a subject that you love.
Chemistry controllers.
Yeah.
I do love them actually.
Yeah.
They are the brains of the operation. They are they're computers, and I love computers. And old controllers were very simple. They just measured pH and ORP pretty much.
And let's just briefly, and I would imagine most of you guys out there using ORP, but the correlation of ORP to true or to ppm is very blurry and vague. And if you start trying to get clarity, the first thing you've got to throw in is pH. And a change of pH of 0.02 will affect your ORP.
100%. Yeah.
And that actually won't affect the test you take. You'll still see the same value of chlorine subjectively when you take your test, but your chlorine has become less effective or more effective.
That's because ORP is not actually looking at the chlorine in the water.
It is not looking at
It's
chlorine.
just the best we had. It was invented about 100 years ago, and it was all we had.
Right, and so the operator takes a value, whatever it's chlorine, and then he'll go back to or she'll go back to the chemistry controller and see a 3-digit number and try and figure out, well, does that actually mean that that number's correct? So what happens is if the chlorine value isn't what they are looking for, a lot of times they'll go and change.
I've seen this so many times. Yeah, they'll change that ORP value.
Right, so you're changing your speedometer again mid-drive.
Again,
correct?
Except this time even worse.
Even worse, because there's a knock-on effect to that.
Yeah, and it's not just pH, total alkalinity, water temperature. There's other values that will change your ORP.
So how do we take that and translate that into the future, changing landscape?
Well, the future is no ORP. We're using true ppm probes. We still use ORP as well as a additional reference and safety. I mean, we are a big believer in having redundancies in place. So if one system's not functioning well, you have another.
Right.
And ORP is such an old technology that we still use it. But, we also have a true ppm probe, which, you see there it says 2.97 parts per million. That means your water should be at 2.9.
So if I've measured my pool at, subjectively again at 2.2, and I guess it's 2.2, and I see 2.97.
Then you can calibrate it. Now you actually are calibrating. You are setting it correctly.
Probably, but you probably shouldn't.
I mean, no, calibrations are never something to be taken lightly. I mean, but you do have to calibrate.
from time to time,
Yeah, my general rule of thumb is once a month.
at the most.
At the most, and it depends on your controller, though. You should always, find out how frequently. They're not all created equal, in a nutshell.
100%. So is there a position, and I believe there is, that you take that by using ORP and true ppm, you can pull down the accuracy
To point one.
to 0.1?
2.1, which means if that it says 2.97 right now. If it's 2.95, that's a little too far off for me.
Right. So you shouldn't make a change. You should technically be able to call your controller supplier and say, what do I need to do, and get that answer in fairly rapid. I mean, as we move forward with technology, those answers should be fairly quickly available to you.
I recommend working with a company who has access to your chemistry controllers and can provide that remote technical support, same day. So
Yeah.
if you ever have an issue, you don't even have to calibrate your controller. You can call someone up and say, hey, my controller's not reading accurately. What do I do? That is the way things are moving forward.
Yeah.
And to that note, if you have more than one body of water, I mentioned being able to remotely monitor them, which is already ahead of the curve. But you have to look at each of those individually, each of those bodies of water. I mentioned that customer that we have 12 pools.
Correct.
If he had to, even if he could remotely monitor them, and he has to look at each of them individually.
By the time he got to the 12th,
Yeah, exactly. So nowadays, there are systems, there are applications out there that will integrate with your chemistry controller, or should, that will allow you to keep track of all of this all on one page. And in addition to that, if there's ever an issue, it will actually send out a notification to let you know.
Well, and that's kind of standard on a number of controllers today. But when we talk about moving to more advanced technology in a pump room, we're talking about AI being able to self-diagnose, being able to let you know what the problem is, and perhaps give you some solutions. But that brings it into, if it's on one screen, there's some option here of trending.
Yeah, so trending data is kind of a new thing.
So don't wait for a problem to happen. Try and catch it before it happens.
Yeah, what I just described was, if there is a problem, it
Right.
sends you a notification. Wouldn't
Sure.
it be great if it would tell you before there was a problem?
Right.
That's what we're kind of seeing now and you can do this with water chemistry. Water chemistry typically changes slow enough. You have the time. If your chlorine is 1 today, and 2 and 3 and 4 and 5 and 6,
And pH.
you know where it's going, whatever the value
Whatever
is.
that
Yeah.
is, yeah. Flow rate too.
Yeah, so a lot of, some modern systems are able to recognize that the data is heading towards an issue and send out a notification before it reaches that point, which, whatever your regulation might be. This allows you to become more proactive.
Right. So what we believe with integrated technology, and we really do, and I say we, the industry is working towards an integrated mechanical room. We've seen that one of the large pump manufacturers has just released a Bluetooth pump for residential.
Yeah.
Residential pools are a lot more integrated today than commercial pools are. We kind of playing a little bit of catch up, but we should be able to see energy, labor savings, cost savings, and obviously the best result of all is healthy water, healthy air, and consistency in your pool. And David, could you talk a little bit about AI?
Yeah, so someday, not soon, but someday, AI will be able to monitor your pump room and, actually be able to determine solutions for you and your staff, and say, hey, here's what's happening, here's what you need to do.
Right, right. Okay, let's sort of move away from the 3 pillars, the learning areas, and talk about ROI. What we've seen in the industry is that since COVID, the cost of chlorine has absolutely skyrocketed. Now, perhaps not in every part of the country, but in a large number of areas, I mean, we've even seen it in Florida where chlorine is a lot cheaper. We've been able to take our system, which was a luxury system, the sustainable salt pure system, and we've been able to show over a 10-year period a substantial cost savings. And we've run ROI analysis on them, showing at the end of a 10-year period and being very transparent with the costs that are incurred by replacing parts in a salt system. You can actually see an ROI. And guys, I'm actually not even talking about ROE, or the return on experience as well. What we find is that people tend to not want to swim in chlorinated pools, traditionally
I know those
chlorinated
people,
pools.
yeah.
Yeah,
I've met a few of those people actually recently who did not want to swim in a chlorine
who
pool.
won't swim in one, yes.
Yeah.
Yeah. So we believe moving into this new landscape, we believe that if you have a supplier, if you have someone that will actually, instead of just service your pool, but that will partner with you to support your pool, your aquatics becomes a lot more simple. You've got somebody to pick the phone up, get online, text, and ask them, hey, I've got this little problem. Can you tell me? If that person is responsible, knowledgeable, and engaged, you can take care of most of your problems in fairly short order.
Yeah, you don't need to always call a pool service company.
Yeah, and wait a week. So we believe that the old model of call a guy up, boots on the ground is changing, and we believe it will continue to change. So with that, here's the commercial side of it, but with that, here's a partial client list that we've had. A number of the folks that are highlighted in red are MFA members, and our team put that together. Thank you. We'd also like to let you know that folks within the MFA have used our system, are using our system with great results. We don't claim to be perfect. I don't think there is a pool system out there that is perfect.
No.
We just try really hard to be as perfect as we can. We've had the Logan Health, I think they've been with us 17 years now, or something like that.
Yep.
So in closing, and to thank you guys for sticking around and listening to our webinar, we would love to offer you a cost comparison. Just tell us what you're paying for chlorine, give us a few data points, and we'll run that 10-year ROI for you. We'll also provide you with direct contacts to folks like Logan and others. And guys, you don't have to buy anything from us to call us up and ask us for some support. David just loves conundrums.
I do actually. I've helped so many people who haven't spent a dime with us.
Yeah, and the point is let's help the industry get better. Let's provide a really, really critical resource to kids learning to swim, to older folks who need to work out. So with that, I thank you very much, David. I thank you.
Thank you, everyone.
Taking the time, and over to you, Marianne.
Awesome. Well, thank you so much for sharing your knowledge with us today. So if anybody has any questions, you can go ahead and type them into the chat or into the Q&A panel. And while we're waiting to hear that, I'll just let you know that all the attendees will receive an email with an evaluation link for today's webinar. And it includes a spot to indicate which CEC you would like to receive. But even if you don't need a CEC, we would love to get your feedback on today's webinar. Our next webinar will be held next Wednesday, September 24th at 1 p.m. Eastern. And this one is entitled Anti-Obesity Medications, Are Diet and Lifestyle Still Relevant? And this will be with Kirsten Taylor, who is the Director of Nutrition at Cooper Clinic. So I also want to let you know that we have our annual conference coming up on November 4th through the 7th. Yay!
Yeah.
Awesome. Being held in San Diego this year. So we co-locate our conference with Athletic Business. So with your MFA conference registration, you actually have access to all of the events and sessions that are part of Athletic Business Show as well, and their big expo and their reception. So we are running a $75 discount during the month of September. This will be the last of our discounts for registration. So get registered if you're planning before September 30th. And on our registration page on the MFA website, there's also a link for discounted hotels. Those do sell out pretty quickly. So definitely get that hotel reserved. Now you can check out on the MFA website under the events tab for more webinars coming up and more information on our MFA annual conference. I see some thank yous from Paul and Doug. I'd like to thank our webinar sponsor and MFA industry partner, TMI Sustainable Aquatics. And you can learn more about them online at tmiaquatics.com. That's tmiaquatics.com. Well, I'm not seeing any more questions. Do you gentlemen have anything?
Done a great job then. Thank you.
I know, or maybe the questions will come early. Everybody will receive this presentation slide deck with all of their contact information. So if something does come up after the webinar ends, you will have their contact information. Is there anything that you gentlemen would like to add in closing?
All I would like to add is please come to the MFA conference in November. It's great. We'll be there, bells and whistles. We'd love to sit down, talk to you, find out what your pain points are and help you out. So other than that, thank you, Marianne, for doing a brilliant job.
Awesome. Thank you both very much, and enjoy the rest of your day, everyone.
Thank you.